Hello dear students, welcome to a new math session. Today we'll be talking about the life application on the slope of a straight line. If we check example 1, in the opposite figure shows capital change of a company during 8 years. The first requirement is to find the slope of line AB, line BC, and line CD. What is the meaning of each? The second requirement is to find the starting capital of the company. So point A is 0.20, point B is 460, point C is 660, and point D is 850. To find the slope of AB, you will see that slope of AB is 10. That shows the increasing of the capital during the first 4 years with a rate of 10,000 pounds. The slope of BC will be 0. It means that the capital was constant during the 5th and 6th years. And the slope of CD is -5. This means that the capital is decreasing during the last 2 years with a rate of 5,000 pounds. The second requirement is to find the capital at the starting of the company. So from the graph, you will see that the starting capital is the y coordinate of point A, which is 20,000 pounds. Example 2. Hazim filled up the 40 liters tank of his car. As covering a distance of 120 kilometers, the fuel gauge shows the rest of the fuel is 3/4 of the tank. Draw a diagram to show the relation between the amount of fuel in the tank and the covered distance. This relation is linear. Calculate the covered distance as the tank is totally getting empty. Here's the graph shown next to the question, and you can see that on the starting point A, the travel distance is 0 and the amount of used fuel is 40. This is the amount of fuel that we have. After covering 120 kilometers, point B is 120 and 30, so the slope is -1/12. This slope means the fuel amount decreases with a rate of 1 liter for every 20 kilometers, which means that 1 liter is enough to cover a distance of 12 kilometers. So the covered distance that makes the tank empty is 40 over the rate, which is 1/12. Then the covered distance that makes the tank empty is 480 kilometers. Let's now move to example 3. The following diagrams shows the relation between the covered distance in meters and the elapsed time in seconds of an object. Determine the position of the object at the starting motion and its position after 6 seconds when t equals 6. Find the slope of the line in each case and state what it represents. So, for figure 1, as you can see here, it starts at 8, and after 6 seconds, it's also at 8. Then the slope here is, yes, excellent, it's a horizontal line, so the slope is 0. So in here, the slope is equal to 0. In figure 2, it started at 12. After 6 seconds, it's 2. So the coordinates of this point is 0, 12, and the coordinate of this point is 6, 2. To find the slope, it's equal 2 minus 12 over 6 minus 0, which is -5/3. In figure 3, it's 0, 2, 6, 8. So the slope here equals 8 minus 2 over 6 minus 0, then the slope is 1. Dear students, we came now to the evaluation part. Please pause the video, try to answer the questions yourself. After finishing, play the video again and check your answer. Let's now see how are we going to answer this question. Bassem drove his car from the city A to the city B. The opposite graph shows the relation between the distance d in kilometers and the time t in hours. The first requirement, what is the uniform velocity of the car of Bassem? The second requirement is to find the distance between the car and the point 0 after 3 hours from the moment of beginning. To answer the first requirement, we're going to find the uniform velocity, which we're going to get it by finding the change in distance over the change in time. So, for number 1, the uniform velocity equals the change in distance, which is 50. This is the first point, 0, 50. And here is the second point, which is 3, 275. So in here, it's 50 minus 275 over 0 minus 3, which is 75 kilometers per hour. So the uniform velocity is 75 kilometers per hour. Requirement number 2, how can we find the distance between the car and the point 0 after 3 hours from the moment of the beginning? So we're going to go here from point 3. From point 3, we'll go all the way up until we reach the line, and we check where did we touch it on the y-axis. So for requirement number 2, the distance is 275 kilometers. By solving this question, we came to the end of our session. Thank you very much, dear students, and wishing you best of luck.